Hello, and welcome to Mad Chemist Science. Today we're going to talk about the scientific method, my style. So by now, as you've gone through your science education, you have some idea of what you think is the scientific method. And it probably looks something like this: observation, research, hypothesis, experiment, conclusion. Repeat. This is not how real scientists work in real laboratories. This is how middle schoolers write lab reports. When I worked in a laboratory, this is never how I went about solving problems. Somewhere in the 1950s, this got incorporated into textbooks and has been taken as gospel ever since. Let me talk to you a little bit about what the real scientific method looks like. The most powerful statement in science is not eureka. It is, I wonder why. It's this initial curiosity that leads to great discoveries. To make these great discoveries, we're going to have to make observations. And these observations come in two different flavors. The first is a quantitative. Quantitative means a quantity, a count, or a number, or a measurement. And the other is qualitative, a quality, something you can describe, like color or smell. So you've made some observations, and you've got some ideas, but you might want to do a little research just to double check to see if anybody else has had the same questions as you. And once you've done this, you can start to come up with something called the hypothesis. Now you have your hypothesis. What next? You perform experiments. This is to test whether or not your hypothesis is right. Now, suppose you come up with something amazing. What next after that? What do you do with it? Well, if you're working in the laboratory, you publish. If you're working here in school, you have it peer-reviewed. That is, pass it off to your lab mate or one of the people in your class to help you double-check to make sure that it works. If you were in academia working in a laboratory, someone would take your findings and then try to prove them either absolutely right or absolutely wrong. It's nothing personal, it's just that's the way it is. Usually it's someone working on their PhD. If it goes really well, you'll end up with something called a theory. A scientific theory is something that holds true time and time again, but it can be modified as new discoveries are made. The atomic theory or the theory of relativity, these are all ideas that have undergone modification. Next is a law. Laws are much different than a theory. A law states that general behavior is observed to occur naturally. They are consistent, and they have not or will not change over time. This brings us to the end of the lesson. Hopefully you've picked up a thing or two. So ask yourself, do you understand that there are many versions of the scientific method? Would you be able to define a scientific theory? And would you be able to know the difference between a theory and a law? I hope you can. Until next time, this is the Mad Chemist reminding you that chemistry matters.